So welcome to day 2 of College Algebra 2.5. So we're going to go back and we're going to do some more just transformations, some translations, and so we're going to look at this one. Now the square root function isn't quite as familiar to us oftentimes as the others, but here's what I know. It's actually part of it's like just half of the quadratic, so it's an x squared but kind of flipped onto its side. It's actually reflected over the line y equals x. So that's for another day, but right now here is where it is. I'm looking at it. So I'm going to see if I can make that a little bit bigger as we go in. Here we go. Do you see that? So the mother function just goes through the point 0, 0 is where it starts because the square root of 0 is 0. Then the square root of 1 is 1. Okay, so now we got to figure out what is the order in which I do this. So we have said that we do all of the right and left movements first. So I'm going to put in x plus 3. And so which way should that shift me? Left 3. Got it. Okay, now we're going to do, there's no stretches or shrinks, so the next thing we do is a reflection. Now this reflection right here, do you see it's inside? So just picture for a second, what do you think is going to happen? Is it going to go do an up and down switch reflection or a side to side? Well, the negative is right here by the x, so that's what happens. So I'm going to put it back in and I'm just going to copy paste this so that I get a different color and you can see it. It flops over. Okay, so now really what it looks like is it went right 3, but that's a plus sign. So really what happened was I went left 3, then I reflected it. Okay, last but not least, what's the last thing? The last thing is always your up and down movement. So what is this going to do? Yeah, it's going to go up 5. And so what happened if I bring this down? There it is. So I started with my mother function. Then I shifted left 3, reflected it over the y-axis, and then I shifted it up 3. So that's something that you're just going to kind of have to, you're going to have to figure out what is the order of things that go. And then when all else fails, when you're not sure, it's always a good option to go to Desmos and try it there to see if you're right. So we're not going to close that down. We're just going to shift it and make it small. Okay, so let's try the next one. So I said I was going to move on to the next one, but then I wanted to come back and show how I actually drew this in by hand. So I went with the black. That was my mother function. And so there's 2 points that you should know on a square root, 0, 0, and 1, 1. And then from there, the next one is going to be over 4 up 2, but I kind of sketched it from there. Then I shifted left 3, that's my green. Then I reflected over the y-axis, that's my blue. And then I shifted it up 5. Okay, now this next one, number 2, says that I have 1/2 x all squared. So hopefully you know that your mother function, that one you've got, so your mother function is an x squared, which should look like this. Okay, quick thought, I've got a point at 1, 1, and I've got a point at 2, 4. And then here I've got negative 1, 1, and negative 2, positive 4. So I would expect that you know that, and if you didn't know that, you could totally figure that out. So now there's only one thing that's happening, and that is right here with this 1/2. So does that mean, like, what happens there? Is that an up and down stretch or shrink? Is that a side to side shrink? Well, do you see how it's in the parentheses with the x? So that means that it's an x, like it's an x movement. And something we know about x movements is that they do the opposite of what we might think. So we're going to stop and we're just going to go into Desmos to see what happens on that, because sometimes exploring on Desmos is the best way we can do it. So here I've put in my x squared. So there's some stuff I can see. I see that it goes through the 0.11, the 0.24, and up higher it would go through 3.9. Over here, -1, +1, -2, 4. So let's go in and we're just going to put in, so I've got my x squared. I'm going to put that in here. And then what's going to happen when I do my 1/2? Well, take a guess. Now what's going to happen? Well, did it get wider? Did it get skinnier? It's like, oh, it got wider. How did that happen? Well, whenever you see the stuff inside with the x, it always does the opposite of what you think. So it feels like up and down it's doing what maybe we would think, but side to side, it's actually a vertical or a horizontal stretch by factor of 2. Because when you're doing the horizontal, it always ends up being the reciprocal of that. So it stretched over 2. So let's go back in and graph that by hand on paper. So I'm just going to draw in the mother function. I know that that goes through 1, 1 and 2, 4 and -1, 1, -1, 4. So it kind of looks like that. And I'll shift it down so it looks a little bit more perfect. So what happens in this one, I guess I'm moving the graph around. What happens in this one, just if I was going to put it in a table, which you don't have to put it in a table, I'm just showing you so you can see the how come of it, because that's what videos are for. Fast forward it through if you don't need this. Okay, now originally, see, since this says 1/2, I'm going to count by 2's. So 0 would still be 0, but now if I put in 2, well, if you did 2 squared, it should be 4. However, this says 2 will take 1/2 of 2, which is 1, and then 1 squared is 1. So over 2, up 1. This one goes over 2, up 1. Okay, what if I did 4? I could do 3, but that would come out gross because I'm taking half of it. So half of 4. 4 squared should be 16. However, this is taking half of the 4, which is 2. 2 squared is 4. So over 4, 1, 2, 3, 4, up 4 right there. And then if I went over 6, half of that, half of 6 would be 3. 3 squared is 9. So over 6, 2, 4, 6, up 9. So that actually, even though it says 1/2, it makes it wider because x things do exactly the opposite of what you think. All right, we're going to keep going. This one, all right, y equals the square root of 2x. So we're going to go in. Do you remember what the mother function is? So mother function is square root of x. Okay, that looks like this. So this is 0, 0. This is 1, 1. And then the next point would be 4, 2. So over 4 square root of 4 is 2. All right, so that's kind of what the mother function looks like. So I'm going to draw that in. Over 4 up 2, over 9 up 3. I don't have to have all those points. I'm just doing that so you can see what's going to happen. All right, now, is that going to be a shrink or a stretch? I'm going to say that's a horizontal stretch. Nope, that's going to be a horizontal shrink. I was wrong. I think that's going to be a horizontal shrink because they always do the opposite of what you think. So horizontal shrink by factor of, so from now on I'll write BFO. bifactor of 1/2. So what does that mean? Well, originally, I'm just going to make a chart so you can see what happens. It's going to shrink by half. If my original x, 0 still will stay at 0. So it's not shifting right or left. All right, now, if I do, let's say x is 2. Square root of 2 is like 1.4-ish. But if I do this, if I do 2 times 2, that's the square root of 4, that gives me 2. Okay, so now, in my new one, I still start at 0, 0, but now 2, 2. All right, now what if I put in 4 there? If I did the square root of 4 would be 2. But now I want the square root of 8. I'm not exactly sure what the square root of 8 is, so I have a handy-dandy calculator right here. Square root of 8 ends up being 2.8-ish. Okay, so that is bigger than 2, so 2.8-ish. It kind of squashed everything back. And so that's what happens on those. So bifactor of 1/2, because inside the parentheses, inside the grouping symbol with the x, it always does the opposite of what you think. Now you might be thinking, hey Beav, you did not ever write down what happened up here. You are right, so I apologize for that. Your mother function was x squared, but then this right here, that was not a horizontal thing. The way that we got flatter was actually that we were stretching out, kind of like when you push down on cookie dough. Yes, it squishes down, or you could pull it out. There's 2 different ways you could get to the same place. This right here is a horizontal stretch. Bifactor, BFO, bifactor of 2. Because it reciprocals, because it's inside with the x. These are challenging. That's all right. So we're going to stop this video here, and we're going to do the next 2 on another one.